Alright, welcome to today's class. In today's class, we will be dealing on implicit differentiation. Usually, in other methods of differentiation, y is on the left hand side and x is always on the right hand side. And also, in other methods of differentiation, you only differentiate x. But in implicit differentiation, you differentiate both x and y simultaneously. Now note this, whenever you differentiate y, multiply y by dy all over dx. So let's take an example. Assuming we are given x raised to power 3 plus y raised to power 3 equals 3xy, and we are asked to find dy all over dx. How do we go about it? First of all, you differentiate x raised to power 3. If you differentiate x raised to power 3, it will give you 3x raised to power 2. And then plus, if you differentiate y raised to power 3, it will give you 3y raised to power 2. Remember, whenever you differentiate y, multiply y by dy all over dx. So let's multiply by dy all over dx equal to, here we have 3xy. So we would keep y and then differentiate x, and also we would keep x and then differentiate y. So let's start with x. If you differentiate x here, it would give you 1, because x is raised to power 1 and 1 minus 1 is 0. So anything raised to power 0 is 1. So we are left with 3 multiplied by 1 and then y plus, now let's keep x and then differentiate y. So here we have 3 x. If you differentiate y, it will give you 1. Y is raised to power 1. According to general method of differentiation, if you differentiate this, it will give you 1 minus 1, which is y raised to power 0. And apart from 0, anything raised to power 0 is 1. This is coming from the zeroth law of indices. So y raised to power 0 is 1. Remember, whenever you differentiate y, simply multiply by dy all over dx. So we have 3x squared plus 3y squared multiplied by dy all over dx equals 3 multiplied by 1 multiplied by y gives us 3y plus 3 multiplied by x multiplied by 1 gives us 3x multiplied by dy all over dx. So we will move all the terms with dy all over dx to the left hand side. So here we have 3y raised to power 2 multiplied by dy all over dx minus, if you move 3x multiplied by dy all over dx to the left hand side, it becomes negative. That's why we have this minus here. So minus 3x multiplied by dy all over dx equal to, so you move the remaining terms to the right hand side. 3y If you move positive 3x squared to the right hand side, it becomes negative 3x squared. So here we have dy all over dx multiplied by 3y raised to power 2 minus 3x equal to 3y minus 3x squared. Here, our next task is to divide both sides by what we have in the bracket. So if we divide both sides by what we have in the bracket, we would have dy all over dx equals 3y minus 3x squared all over 3y raised to power 2 minus 3x. So this is our final answer. Example 2. 3x squared plus 6y plus 4x squared y cubed equals 5x, and we are asked to differentiate this using implicit differentiation method. How do we go about it? So here we will differentiate x and y simultaneously. If you differentiate 3x squared, it will give you 6x, and then plus, if you differentiate 6y, it will give you 6. Remember, whenever you differentiate y, multiply by dy all over dx plus, here we will differentiate x and keep y constant, and also we will differentiate y and keep x constant. So let's start with x. If you differentiate x, it will give you 2 multiplied by 4 is 8x, and then y, which is our constant, y raised to power 3, plus, now let's differentiate y and keep x constant. We have y raised to power 3. 3 multiplied by 4 gives us 12. We keep x constant, and then 3 minus 1 is 2. So y raised to power 2. Remember, whenever you differentiate y, multiply by dy all over dx. And then equal to, if you differentiate 5x, it will give you 5. So our next task is to assemble all the terms with dy all over dx. So here we have 6 multiplied by dy all over dx plus 12x raised to power 2 y raised to power 2 multiplied by dy all over dx. Equal to, and then the remaining terms move to the right hand side. So we have 5 minus 6x minus 8x y raised to power 3. If you move positive 6x to the right hand side, it becomes negative 6x. And then if you move 8x y raised to power 3 to the right hand side, it becomes negative 8x y raised to power 3. So we bring out dy all over dx. So dy all over dx into this, it gives us 12x squared y squared plus 6 equals 5 minus 6x minus 8xy cubed. So our next task is to divide both sides by what we have in the bracket. So we'll divide both sides by 12x squared y squared plus 6. So dy all over dx becomes 5 minus 6x minus 8xy cubed all over 12x squared y squared plus 6. So this is our final answer.